Hello everyone, this is Zhao Qin. I'm an assistant professor in Syracuse University in the Department of Civil and Environmental Engineering. Today I'm very happy to share our recent work that combines experimental synthesis and characterization with a data-driven machine learning model to investigate the recipe of producing wood composite with mycelium fibers. So we end up with mechanical samples of both lightweight and strong feature. So wood composite combines several components, including wood particles and fibers from different sources, as well as synthetic adhesives. Synthetic wood adhesives are widely used. They have disadvantages, including durability to humidity and aging in time. So they can cause the wood plate to wrap, and they also generate long-term environmental effects. For example, volatile organic compound known as VOC, such as formaldehyde. So they get slowly released during time. Moreover, these synthetic adhesives are derived from non-renewable sources, for example, petroleum and natural gas. So these are limited by their storage in Earth. Here, so instead of using traditional synthetic adhesive, we focus on exploring using mycelium to obtain the wood composite. So it has been observed. It can be observed. So during the hikings, as you can see, those mushroom fibers. So once they grow, they can integrate wood fibers nearby, and they can generate a large piece of plate after fully grows. So we think that can be a good natural solution to bind wood fibers together. And it will be environmentally friendly composite and have good lot of advantages over synthetic adhesives. However, the development of growing mycelium-based wood composite is still in its infancy, and it's not standardized. And there need to be some solution to obtain the optimal material property. So to obtain those solutions, so we grow the mycelium composite by ourselves in the lab, and we characterize the mechanics of those samples. So we use the spout of king oyster mushroom for our study because they are widely available. After these myceliums occupy the entire wood substrate, so we use a heat press method to turn the mixture of wood pieces and mycelium into a mechanical sample. So we tune the pressing time, the temperature, and the pressure, and study how the mechanical function will be affected by those processing conditions. As the result, we obtained the composite sample with an ultimate strength of up to around 13 megapascal, with a Young's modulus of up to 3.66 gigapascal. So these mechanical features are close to these of mid-density fiber board. So to further understand how to improve the design, so we use machine learning, so enabled by artificial neural network to build a model based on our available experimental data. So this model can predict the mechanical feature of any composite for any treatment conditions. So these conditions does not even need to be actually performed. So this can be predicted by our learning model. So the results of our tensile test show that mycelium-based samples has a higher ultimate strength than those samples without mycelium. Moreover, our machine learning also provide a more reliable direction of further improve the mechanics of the composite. So it can guide the design of wood composite for certain by tuning the specific treatment condition. Our study also shed light on developing new wood composite made of mycelium instead of synthetic adhesive, so can learn to environmentally friendly composite for wide engineering applications. So the mycelium species and the substrate type choose for our study are commonly accessible. Our experiments show that by integrating experimental tests with machine learning, we can effectively obtain multi-physics prediction within a high-dimensional design space that the limited amount of experimental tests cannot fully explore. So the development of mycelium-based wood composite will start from the lab by understanding the mechanism of mycelium growth and the structural mechanics relation, but it can also scale up to large-scale manufacturing for engineering applications, including application to infrastructure and packaging industry. So we are working toward this aim and hope the mycelium can make wood composite more environmental friendly in the future. Thank you for listening. Please check the link to our paper if you want to know more about the detailed information.